Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an interesting radical equation with complex numbers. Now, why is this equation interesting? Because if you think about it in real terms, I mean a real solution, then it cannot exist because square root of z and square root of negative z cannot be defined at the same time unless z is 0. And as you know, z is 0 is not a solution, right? Did you know that? I hope you did. So z is definitely non-real, but how do we find it? That's a really good question. Let's go ahead and explore that. First of all, we can think about this problem, I think, in two different ways. Let's try two different methods. How about that? First method, I'm going to go ahead and square both sides, but I can do it in different ways. I can square both sides and then isolate the radical and square one more time, or I can isolate one of the radicals and square that way. I think either way it's going to be fine, so let's just square it as is, and then that's going to give us a squared plus b squared, which is, oops, I forgot to write a negative z, plus 2ab, that's going to be 4 times square root of z times the square root of negative z equals 25. Nice. This will give us negative 3z, so we're going to get negative 3z plus, I could probably write this as 4 times square root of negative z squared, and then that's equal to 25. And of course, I want to isolate this radical one more time and then square both sides, because we want to get rid of all the radicals so we can just, radicalize this, okay? So this gives us 16 times negative z squared equals 625 plus 150z, the 2ab, plus 9z squared. That's negative 16z squared. Let's put it on the right-hand side. Add it, 25z squared plus 150z plus 625 equals 0. Nice. Can we divide by something? Possibly 25? Absolutely. If you divide by 25, you're going to get z squared plus 6z plus 25 equals 0. That's really cool, isn't it? Well, maybe. You can use the quadratic formula or completing the square. I think completing the square will be fun here, so let's do that. I want to go ahead and add 9 to both sides and just think about why you would add 9 to both sides, because we'll answer that question right now, because that gives you the following. Now from here we get two things. Z plus 3 is, wait a minute, are we supposed to square root a negative number? Yes, of course. It is going to be 4i with a plus minus sign. So I can kind of write the z values as 3 plus 4i, or z equals 3 minus 4i, right? Good. Now, how do we pick the right one? Does there have to be a right one? Or are they both right? Good questions, right? So we're going to try to explore that a little bit, because something we need to talk about is the principal square root. When you write something like the square root of z, you're not being very clear if z is a complex number, because a complex number has 2 square roots. By the way, if you're new to complex numbers, go ahead and check out my lecture videos, because I go over all these topics. And even if you're not new to complex numbers, just go over them for fun and just give me some watch time, okay? If you also like algebra and number theory problems, just kidding, you can also check out my other channel, which is Cyber Math. Okay, so what is the principal square root? We said that their complex number has 2 square roots. Why? Let's think about it. Take 2 plus I, right? There's a reason why I pick it. It's 4 plus I squared plus 4i, which is I squared is negative 1. Don't ever forget that, please. 3 plus 4i. Uh-oh, that was definitely on purpose. I knew that. So 2 plus I squared gives us 3 plus 4i. But if you square negative 2 minus I, you still get 3 plus 4i. So this number has 2 square roots, but only one of them, the one with the positive real part, is considered the principal square root of that number. And of course, that will have, I think, an argument between negative theta, and one of them is not included. I think this one is included, something like that. But the idea is you have to be picky, and when you say, for example, if you say the square root of 16 is 4, right? You don't go with negative 4, because in the complex world, 16 has 2 square roots, but we take the 4 to agree with the real world so that they can kind of agree on each other, right? So that's why it's important to stick to a convention. That's why we have to be super duper careful. Are both solutions valid? Maybe after the second method, we're gonna go ahead and discuss that. Okay, let's go ahead and take a look at the second method. I think second method is really cool because it does not require, well, almost no squaring both sides. Okay, so square root of z plus 2 times the square root of negative z equals 5. Here's what I'm going to do. Square root of negative z is negative 1 times z under the radical. Can I write it as square root of negative 1 times the square root of z? Of course, this is not always valid. You got to be careful, but this is just I. Remember, the principal square root of negative 1 is I, so this becomes I square root of z. In other words, our expression becomes square root of z plus 2I square root of z equals 5. Now, you know what I can do? I can take out the square root of z and write this as 1 plus 2I equals 5. And then I can divide both sides by 1 plus 2I. And of course, you can't just divide by a complex number, but you can multiply by conjugates, right? And when you do, you're going to get 5 times 1 minus 2I. And this one is going to give you, from difference of two squares, will give you a sum of two squares, 1 squared plus 2 squared, which is 5. So they cancel out, leaving us with this. Root z is 1 minus 2I. That's kind of problematic, isn't it? Why? Because if you really think about it, when I said, okay, 3 plus 4i is 2 plus I squared, but when I square root 3 plus 4i, I get 2 plus I. Do I get 1 minus 2i? Probably not, but we can always talk about it, right? Let's go ahead and square both sides, because my goal is to get to z. Z becomes 1 squared plus 2i squared, which is 4i squared, which is negative 4, minus 4i. And z from here becomes negative 3 minus 4i, which is definitely not the principal weight. Well, I'm talking about the principal square root, not the principal value of this original number, because z can be anything pretty much, right? So what does that mean? If z is equal to negative 3 minus 4i, that was not one of the solutions that I found. So there's a problem with the second method, because when you write square root of z, the square root of negative z, when this is the principal square root, this does not have to be the principal square root. You know what that means? Depending on the quadrant, because you're cutting the angle in half. For example, suppose you had an angle like this. Let's just say, is it 7 pi over 4? No. Okay, 1, 2, 3, 4, 5. Okay, it's 5 pi over 4. Half of that would be 5 pi over 8. Think about which quadrant that's going to be. Or if you have 7 pi over 4, its half is going to be different. You see, depending on where z is located, answers may vary, but my first method seems to be fine. But why don't we check with Wolfram Alpha? Let's see what it says. From here, I got a different solution, but is that a valid solution? What do you think? Let us know in the comment section, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.